In this activity with exploding soap bubbles, we're going to investigate some really exciting and interesting chemistry. At the same time, it's very important to work safely, so we suggest that you start by preparing your students on how to behave and how to take precautions. First of all, no long sleeves, and if students with long hair should wear a hairband and take their hair away from the face to prevent it to hang down like this. And secondly, because you will use matches and make soap bubbles explode, it's nice to have, or smart to have, a fire blanket ready in case of something unexpected should happen. Actually, I have once myself really been very happy I'd had this ready when some cooking oil caught fire on a desktop in a classroom. I just took the blanket and it was gone. Very nice. And they also have to work with safety goggles in this experiment because we will use acetic acid and we will have soap bubbles explode. So, so that's the most important. It's also important that they work on a foil of aluminium because aluminium doesn't catch fire, and this gives them like a safe structured area to work on. So that's also structuring them when they do the experiment. So that's the security of the experiment. Actually, there's one more thing. You're gonna produce hydrogen gas in these bottles, and they come from the producer with a closed end here. So it's extremely important to cut off this end to have an opening here. Actually, I will do it before, or we will do it before we ship them out to you, but maybe if we forget, please check that it's an opening on all these bottles because we don't want the development of gas in a closed container. That's dangerous. Okay, then you could start to talk about the chemistry. And you can tell them that in this experiment we will use an element or an atom, type of atoms called magnesium. And this is a magnesium band. And if you have been working with atoms and a periodic table, it could be a good idea to look at where do they find magnesium in the periodic table. You can tell it's written Mg, and you find it here as element number 12. And you may, if you have talked about electrons and shells, it could be interesting to start to ask them how many electrons does magnesium have in its outer shell. And some might then suggest 2 electrons. Okay, and what is most easy, you can ask, for magnesium to obtain a full outer shell? Is it to give away 2 or gain 6? And you can tell them, if they don't guess it, that it's easier for magnesium to give away 2 than to obtain 6. Okay. And then you can start either in a beaker or in a petri dish. You can take some acetic acid vinegar, diluted to 5%, and you add the band of magnesium. But before you do that, you could also ask them, what do they think will happen? Here they have an atom that easily gives away electrons, and in this acid we have something we call hydrogen nucleus. We have H+. So this is like a hydrogen core without any electrons. And maybe some will figure out that hydrogen receives electrons from magnesium and produce hydrogen gas. But just put it in here, and immediately you will see bubbles coming up. And it's interesting for everyone to just see this because it's so immediate and very, very obvious here that a gas is produced. And you can tell them that this gas is hydrogen gas, H2. And it's very flammable, full of energy. And now we are going to explore that further. So I can put this gas here, and I will show you the next setup. This time we will have put on safety goggles. I should have done that earlier, but now I've done it. And we will have now vinegar, acetic acid diluted here in the pipette bottle. half full approximately. And then we will add a new band of magnesium to this bottle. And now I suggest you divide your students in group. For example, a group of 4 to 5 students, and they can work together around a sheet of aluminum foil. And immediately when I put this band into the bottle, I see hydrogen gas forming. And then I need some soap bubble solution in my Petri dish, here. And the trick then is to transfer or lead this gas into soap bubbles, and for this we're using a straw. And unfortunately we haven't been able yet to replace this plastic straw with a paper straw because we need this bend, but we're working on it. So well, here we are now have gas is now developed, and I just put the straw into the soap bubble solution, and immediately I see bubbles coming up. And of course the first bubbles coming here now also contain air, because there was a lot of air in the bottle. So in the beginning, some students are disappointed when they try to light or ignite these bubbles, because there is not much happening really. But I can try now. Yeah, see, there was not very impressive really. But we will try again. And soon it will be more noise and flash coming out of them. And actually, before you do this experiment, you should ask them if they have practiced lighting matches. And if not, you should actually start by just practice lighting matches above aluminum foil. Because many children today don't have that practice. They have never learned it at home. Let's see now. Oops, one more time. Yeah, that was much better. And of course, some students will always try to ignite this bubble. And that's one reason it's very important to wear safety glasses, because then it can be a bit more explosion happening here. But I won't do that. I'm very careful. So and of course now they should take turn holding the straw, lighting the bubbles, and you should open the windows to get out smoke. And usually the fire alarm doesn't go off. So actually I've never experienced that, but open the windows if you can. It may also be done outdoors, actually, if you don't have much wind. You can do it outdoors. So, yeah. The trick to get big bubbles and not too many small bubbles is to hold the straw on top of the bubble. If you instead dip the straw down into the soap bubble solution, you will get many small bubbles, and that's not that exciting to light or ignite that one big bubble. So here I have one big and several smaller ones, and I will ignite them. And of course then it's interesting to ask what's actually happening when we ignite these bubbles. Why do that you hear a light or hear a sound and you see some light coming out? Well, that's because energy is released in this chemical reaction. And you may then ask, what is hydrogen reacting with? What's happening here? And what's in the air that could react with hydrogen? And try to lead them into that it is actually reacting with oxygen, and the result is water. So this chemical reaction, the production is energy and water. And that's why many companies and researchers today are working to produce hydrogen-driven cars, etc., because that's a very environmental friendly way of producing energy. So this is a way to widen the perspective at the end of the experiment. And if your students have the focus and the energy, you could also build models of this chemical reaction if you have molecular building sets. You can start with oxygen, and you can start with hydrogen, and you can build water, and then you will see you'll need 2 molecules of H2 for 1 molecule of O2 to build 2 molecules of water. So that's like a chemical equation. Well, good luck. When you've finished, it's very important that the remains of this magnetic band is kept in an airtight bag, because it can ignite by itself at room temperature under very special circumstances. So to be precautious, just put it in an airtight bag.